Hello ladies and gentlemen, and welcome to my channel. Today I'll guide you through detecting content zones in a research paper, whether it's text, figures or tables, by fine-tuning YOLO v11 using custom datasets from the Roboflow universe. Detecting content zones is a crucial step in automating and enhancing document understanding. It minimizes manual effort while improving the accuracy and efficiency of document processing systems. In this video, we will cover the following steps: setting up your API key in Google Colab after creating a Roboflow account, using a free T4 GPU in a Colab to speed up the training process, analyzing the datasets including class instance counts, fine-tuning a pre-trained YOLO v11 nano model for better performance, evaluating results using metrics like the confusion matrix, F1 score and precision, testing the model on your own images to validate its real-world applicability. So if you are interested, stay with me. Welcome back. I will share with you this notebook. First, you need to create an account in Roboflow universe. So search for this keyword. So this is the official website, universeroboflow.com, and here we are going to use this data sets are XIV paper. Search for this. We are going to use this datasets, data tables, which contains 8.6 thousand images with 3 classes: table, text, figure. So this is the datasets. So first you need to set up your API key. To do that, go into my account, my projects, settings, API keys, and copy this one. Create new secret key, pass it here, and this is the key of this secret key, and I activate it. And now let's try to run this block. So here I install the Roboflow, access to this secret key, and I try to upload the datasets. From here, as we see here, I upload the datasets in this account. So as we see, data table ones, and I try to extract it automatically when I run this block. After 1 minute, this block finished. So let's see data table ones. So here I extract datasets. So as we see here, we have 3 folders: test, train, validate. We have data YAML, number of classes 3, figure, table, text. Let's see the train. The train have 2 folders: images and labels. Let's see the images. So as you see, this is the images and this is the labels. So this is all the bounding box. So this ID class and this is 4 float numbers represents the bounding box. So now let's try to analyze these datasets. Here, counting the number of classes in each subfolder. This function to count class ID in a single file. Here we have a function to count class IDs in all files in a folder. Let's run it. So here we try to count the number of images in train folder, test and validation folder, and here we have all images 16,351. Counting classes in train subset. So here the path to labels. So here I copy the path and pass it here. We have 60,000 of text and 8,900 about tables, and this is the figures. So here counting classes in test subset. Let's run it. So this is the result for test subsets, and let's see for validation subsets. This is the path for the validation. So now let's try to install ultralytics to custom this YOLO model. So here we are going to use nano pre-trained model. So as we see here, we have 5 pre-trained model: nano, small, medium, large, and extra large. So we are going to use this model, the first line, call this model, and here we need to put the YAML data file for 10 epochs, and we resize the image into 640, batch equals 16, and plot true and device equal 0 to use the GPU. So let's try to update data YAML. So here we need to put the path into train images. So go into train images and copy the path and pass it here. The same thing for validation. This is the validation. So here I put, instead of train, I put valid, and for test I replace train by test. And let's now try to run this block. So as we see here, we have YOLO 11 nano. So this line download this model. So as we see here, we have 15,490 images, and here the training start. The training use 2.6 RAM from the GPU and 4.4 for RAM system. This is the upper parameters used by the model. So I stop the record after the training phase finished. The training phase took 1 hour. The first epoch took 6 minutes 20 seconds, and this is the time for the second epoch. And this is, for example, here we have 6 minutes for epoch number 10, and this is the metrics. So here we have images, instance, box precision, recall, mean average precision 50. So the model performs well. So let's run the relation between F1 and confidence curve. So this is the result. Orange represent the table and green represent the text. Recall and confidence. So here we have train without for, recall and confidence curve, relation between precision and confidence, and here the confusion matrix. So here in the text we have 41 predicted as a false. In general, the model performs well. So let's see the results matrix. So this is the train box lose, validation box lose. This is the train class lose and validation close. This is the precision, validation, or here metric, mean average precision. So here we have ARGS YAML. So this is all the default parameters. Here we choose batch 16, patient 100. We have 106 parameter.
I can download the result in CSV format. So this is the result after I draw metric mean average precision and metric mean average precision between 50 and 95. And here we have train box loose and validation box loose. And here the metric for precision and recall. So the same thing in this figure. So here I download the best model. So this is the pre-trained model. So I try to download it. So this is the model. For the future work, I use just this model, best.pt. So here I try to show some validation batch prediction. So as we see here, this is a figure predicted by the model, and this is a table, and this is the text. So as we see here, figure, here a text with the confidence 1. Let's see the second validation batch. So here this is figure, text. So here let's try to validate the model and see what happened. The path of data YAML, I run. This is the result. So here prediction test. So here I have some images and I try the model with these images. In the test images, I try this image 1, 2 and 8. So here let's create new folder and rename it test images and try to import these images. So I choose these names. So this is the prediction section test. So here we copy the path for the pre-trained model. So in the run, detect, train, weights, and I copy the path to pass it here, and here I copy the path for the images which I upload. So inside test images, copy the path and I pass it here. So here the same thing for the second one. So here I change 1 by 2 and the same thing here. I change 1 by 8 and I run. This is the result. In the first image we have 5 taxes. Let's see. So this is the text. This is the confidence score. An abstract. This is also the text. So as we see, the text detected correctly. Let's see the second one, and this is a figure. And here we have a table with 0.9. Also the table detected correctly. Thank you for your attention, and we will meet in other videos.